I'm incredibly excited to have Michele Catasta.
Perfect.
All right, I nailed it. I lived in Italy for 2 years, so I've got a pronunciation down a bit. Here to chat about the Replit Agent and really all things Agent-T related. So we'll do about 20 to 25 minutes of a fun chat, and then we'll open it up for questions as well. So if people have questions, think of them throughout, and we'll go around at the end and call on folks. So maybe to get started, could you walk us through a little bit of the history of Replit Agent, how it came about, what the idea for it was, the timeline to launch, which was 3 weeks ago at this point, and then maybe what's happened in the past 3 weeks as you went pretty viral, I'd say.
Yeah, not much sleep in the last few weeks. Also before the launch. Launch was September 5th, so it has been a while. All right, so timeline has been the following. I started the AI team at Replit in early 2023. And then I wrote the Replit AI manifesto. Maybe some of you wasted a few minutes reading that. And back then I had this idea that we saw the React paper, we saw LangChain growing and all the initial agentic workflows that you were offering in your framework. And we realized, okay, we have a tremendous opportunity at Replit because all the tools and all the devices are well orchestrated in that platform. The only ingredient missing is an AI that really lowers the barrier of entry to software creation and allows basically everyone to build 0 to 1 without writing a single line of code. It took us a while to get there. I think it has been 15 months between me writing the manifesto and us launching the agent. And I would say things accelerated in the last few months in the sense that we built a lot of the foundation and scaffolding throughout 2023. Like we included a state machine inside our chat server. Remember we talked about it back in the days. We started to expose some of our internal tools with APIs that were more amenable to be used by an LLM. And then in the last few months, we basically made this big bet of kind of rallying a good chunk of the company beyond Replit Agent with possibly a different take compared to most of the other coding agents that you see on the market. Our goal is to actually build a product rather than a replacement for a junior software engineer. I think both approaches are great. I think some of them are targeting full autonomy. Replit is more somewhere in between on the spectrum where we want the user to be at the center of the product. We want you to be engaged. We show you what the agent does. We ask you questions. We ask you for feedback. And we found out that by building something more engaging, we also probably address one of the hardest problems in agents, which is the fact that they make a lot of mistakes. So if you trust them over a long trajectory, eventually they're gonna either crash or not accomplish the goal that they have in mind. And we tried basically to recover that by asking the user often, is this what you want? Shall we revert back? Shall we build something different? So that kind of balance seemed to have excited a lot of our users. And then the rest is history. We launched early September. We saw way more people than I ever expected building with it, to be honest. And it has been very exciting to receive feedback.
Can you share any metrics on how many people have used it and what the usage looks like?
I don't know if I'm
all right.
I can tell you we had hundreds of thousands of runs in production, as you know, because we are using your services as well. So
yes, I think Alex on our infra team is very aware of that.
I bet.
You talked a bunch about the UX already, which I think is one of the interesting parts. But how do you balance the, it's kind of annoying if the agent always asks you for more things and more things, but it is good for it to ask you about some things. So how do you balance that kind of like trade-off between it asking you for some things, but not
all the time?
Yeah.
Yeah, first of all, very hard problem. I will say a disclaimer. I don't think we cracked it perfectly yet, so we still get some feedback. Sometimes we ask questions that are considered too trivial for some users. In a sense, what we do is we have a lot of tools in the scope that one of our agents in the multi-agent architecture we built can use. And depending if we go like straight to completing a step successfully or not, then one of the tools that the agent can use is either like taking screenshots or running static checks on the code, executing and see if there are errors in the console. But last but not least, if we see that no progress is being made, then kind of as a last resort, we go back to the user and ask, given this error that we're seeing, can maybe try the web application with these inputs and tell us, what are the issues there. I think we get it right most of the times, but.
And is that a tool that the agent can call, basically like ask human input as a tool, and then it's prompt engineering to get it there? Or do you do things like, hey, if it's run for like a minute, let's like ask the human no matter what, more kind of like deterministically?
Everything you said, plus it's also a sub-agent. So we have a verifier tool that we invoke in specific occasions. We also have this multi-agent team that has a manager, it has editors, pretty much like in any software team in the real world. And we also have a verifier that is allowed basically to go through the app and interact with it to a certain extent. And yeah, last but not least, we basically collect all the outputs from tool, and that gives us a glimpse of what is going on in the application.
Let's talk about the multi-agent stuff a little bit more, because I think that's really interesting. How'd you arrive at that? And what are the different agents and what's different about them? Is it the prompts? Is it the tools they have?
Yeah, so we have this, first of all, we built a multi-agent architecture for possibly what is very well known by now in the community. It's very important to, in a sense, separate the scope, make sure that agents, every sub-agent has the least possible amount of tools visible, and also the least possible amount of instructions. And the rationale behind it is very easy. The more you expose to a sub-agent, the more opportunities it has to make the wrong choice.
And did you start from this? And you
No.
kind of okay. So yeah, what did you start with, and how'd you arrive there?
We started with the simplest possible architecture, which is React. And the reason is, I think everyone agrees that it's the simplest and I would say the first step that everyone takes when building an agent. And then we started to explore how to integrate different tools. And the moment we had too many tools and we started to see too many errors, then we realized, okay, maybe now we need to step up our architecture. I knew about multi-agents. I've been reading also your blog posts and all the research papers. I think there is value in building things incrementally. That's why I'm also excited about what you're doing with LangGraph. In a sense, you can plug or change your architecture in a few lines of code and see what pays off. I'm not a maximalist of multi-agent architectures. I think they make sense for some tasks, but I know a lot of startups out there that have basic agents deployed that are extremely successful and powerful. So I would say the right architecture comes with a specific requirements that you have.
That makes sense. You talked about tools a few times, and tools are obviously really important for agents. What are the tools that your agents have access to, and how do they call those tools?
All right, so we have pretty much every tool that you use on a daily basis as a developer. We expose them to our agents. So everything that you find today in Replit has literally in our tool panel.
How many of those did you have before? Because you're Replit and you have all these things versus writing from scratch for agents specifically.
We basically had maybe 90% of them already. Some of them were almost there. We never thought of wrapping them as tools. They were somewhere hidden in the code base and they didn't have a clear API. And we just had to make the additional lift to expose them as an API. But overall, Replit has been built over the last almost 8 years at this point. So all those tools existed. The challenge is not, at least in our case, to build the tools, is how do you expose them and how you orchestrate them with an LLM. And there is this field, I think, that this WeAgent paper calls ACI, so the Agent Computer Interface, that I hope is going to be flourishing more and more. Because the real challenge, again, is not building a tool that is reliable. At the end of the day, tools are software. I think we know very much how to build reliable software, but today is actually how to make reliable the interface between the LLM and the tool per se.
What does that mean exactly? What specifically did you guys do for that?
So we started from function calling, pretty much everyone does out there. The function calling APIs, either from OpenAI or Anthropic at this point, are fairly elegant and easy to use. The truth is they're also fairly limited. And for those of you who went through the pains of making function calling more reliable, I'm sure you have seen all these tricks where you should reorder the way in which arguments appear. Maybe you should rename in such a way that you kind of invite the LLM to reason before they actually create the function call. And it turns out that we try to push the envelope in that direction as much as possible. We kept hitting walls until we took a complete detour and we decided to invoke tools with code. And the reason is LLMs are amazing at generating code. I don't have to convince anyone about that. So rather than going through the function calling, we decided, okay, we give all the information needed to the model in the context. We ask it to reason. So we go through a long chain of thought whenever needed. And then the last action that the model takes is actually generating a Python DSL, it's literally a stripped down version of Python that we parse on our backend. And then if it's compliant, we know that that's a valid tool invocation. And if it's not, we keep retrying. We made that way more reliable before launch. I don't know the exact numbers or now, but we are literally surely above 90% success rate.
Success rate of generating a valid tool call?
Yeah, especially because our tools are not easy to invoke. Like some of them, of course, we have one argument tools like everyone else, but some other tools are fairly complicated. They have a lot of arguments, a lot of different settings. So it wasn't viable to just do function calling.
What do you do when it generates a tool call that's not valid?
We retry. And luckily Sonnet seems to be very powerful. We have a couple of, let me talk about the other fallback solutions. To be honest, retries goes up very, very far most of the times.
And retry is just like straight retry with no changes to the prompt, or do you pass back in like the error message?
We pass back, what happens. So like most of the times, even from that basic self-debugging, it already understands how to make progress. But as some of you told us already on X through your feedback, I would be lying to you if I told you Replit Agent never gets stuck. Especially when we launch it, we found a completely new class of errors that we never thought about before. So thanks again for the feedback. Now I think we're in a better place, but at the same time, there are situations in which the tool usage is wrong, and then we brought in reflection as a technique, which basically allows us to attempt a few steps, and then we stop at this point, I think every 5 steps, depending on how you define steps in our agent. And we should talk about trajectory length after. I think it's gonna be fun. But like every few steps, we stop the word, and then we ask the agent to reason if it actually made progress or not. And that's another basically recovery strategy where even without user feedback, we roll back to a previous state and we restart. And that usually adds enough randomness to the process that allows us to go down a different path and actually succeed.
Let's talk about trajectory length since you brought it up. What's going on behind the scenes? How many LLM calls? How many tool calls? How long does it take on average?
All right, so trajectories are definitely in the order of tens of steps. We have seen several of them going over the hundreds. It really depends how, I would say, stubborn or affectionate a user is, depending on the point of view. And I'm excited because we saw some people spending hours on a single project with the agent, and the agent actually accomplishing what they wanted. So that feels really awesome. It's not always the case, but we're actually getting there. The shortcoming of longer trajectories, of course, is the fact that you need to represent in memory useful information in order not to get the agent completely lost. So you need to retain part of what happened in the past without overwhelming the agent with unnecessary memories. So the crux of long trajectories is memory management, which is like a very hard problem that I don't think anyone in the field has still cracked completely. But the moment we get there, I expect trajectories to become like even more ambitious in terms of length.
And so right now, like, what does memory management look like for you guys? Is it simply the last 10 steps and you pass those in, or is there some smarter heuristics on the back end?
Yeah, we have quite a lot of heuristics. Definitely, there are some truncation criteria to manage. We try not to keep the entirety of the memories. We compress memories, both in terms of like past steps that appear not to be relevant any longer. Also, when we jump between one sub-agent to another, the way in which we compress memories also in that case. Whenever we succeed in a step of our plan, we basically compress that memory even further and then just have like a high-level description of what happened in the past. So we have all these bag of tricks that we applied in order like to have more reliable, longer trajectories. The truth is, even if you have a very high probability of success on a single agent step, if you just compute the compound probability, you will see that the reliability drops very quickly after like 50 steps. So I would say the main insight that we used in Replit Agent was to do as much progress as we could in the first few steps. That is possibly the best recipe to avoid the issue of long trajectories, actually not to allow a user to go that far.
You mentioned a few pretty complex things or things that you iterated on. So like the generating tool calls as code, the memory management, these long trajectories. How do you come up with these kind of like ideas? Like for the prompt engineering of putting things as function calls. One, like, how did you came up with that? Well, who's doing the prompt engineering? We hear, is it engineers? Is it subject matter experts? In this case, are they the same persona? So it's the same people doing both. Curious what that prompt engineering process looks like.
You'd be surprised how small is the team that actually work on that. I think half of them are in this room today. But I would say we wear both hats. So they are like very good engineers. They also have a good understanding of how LLMs work. And like I come from a background of training very large models, so hopefully sometimes I bring in like some good insights. And last but not least, I love the fact that the agent community is building mostly in public, like including you guys. Both the quality of the documentation you publish and the fact that a lot of these recipes are already in your code base basically allows us to be a bit more relaxed in terms of thinking. Like at this point, it's more about cherry picking what we think works well, rather than having to come up with new techniques. I think all the ideas are out there. It's more about discerning which ones are good or not good for our specific work.
You mentioned that you have a background in model training and that these agents often have tens of steps. What, to the extent that you can say, like what do the models look like that you're using under the hood? Are they ones that you've fine-tuned yourself? Are they off-the-shelf ones? Are you primarily with one model provider or swapping around between a bunch of them?
So at the beginning, we tried a lot of different things, including fine-tuning frontier models. And right now, we are mostly relying on Claude 3.5 Sonnet, which we find to be awesome in terms of anything code generation and code editing. It seems to be like a step function improvement compared to other models for these specific tasks. So yeah, most of our LLM calls go there. Then we have a long tail of calls to Foro Mini for compression or like for other watchdog works. And we tried also, we have some other fine tuning that we do also on our embedding model, like to retrieve the right data from the file system. But yeah, I would say the staple right now is working with 3.5 Sonnet.
We get asked a bunch about the trade-off between like accuracy and cost and latency. So how did you think about that when you were developing Replit Agent?
Let me stack rank them. Accuracy, by far. Cost, otherwise eventually we're gonna go broke. And latency last. I know that maybe this is not gonna make some users happy because at this point we as a community, not we only as Replit Agent, we keep raising the bar like on a weekly basis. People want things to get done magically and always faster, always more efficiently. The truth is like optimizing the triangle as of today is pretty much impossible. So I would say I'm happy to trade latency in exchange of much higher accuracy. I would say that is by far what makes the user most frustrated. And then of course cost eventually will play a big role, but we all are making the assumption that frontier models will become cheaper, and then when the next generation of model comes out, for Omni or Sonnet will be so cheap that agents will be way more affordable.
You've talked about a bunch of complex things happening behind the scenes. How do you debug what's going wrong in these agents? And before this, I'm cheating a little bit because you told me a fun story about how some people were debugging things on your team. But yeah, what does that process look like?
Yeah, so we adopted LangSmith very early. I think maybe the first month that we were betting on the agent, I immediately brought up the requirement in the team that we need a way to observe the agent behavior.
This wasn't intended to be a promo. There's actually a much cooler story that he's going to tell shortly, which is what I'm really interested in.
The story is coming, but also as a personal recommendation, don't start to do any serious agent work without any level of observability. Every person who built any system, like distributed systems, whatever that is, they will all tell you exactly the same war stories. If you don't have a way to observe how your system behaves, you're basically just building a prototype. The moment you go in production, you're gonna regret not having a way to poke into the system. So we needed exactly the same when we started to build the agent. So we jumped on LangSmith right away because we're already using LangGraph, and we basically grew into that, and we had to learn how to use it. It's much different compared to any other observability tool out there. Also, back in the days, our traces were much shorter. Like our needs kept growing, the more powerful the agent became. One trick that we've been using recently that I found very exciting is in the LangSmith trace, at every single step of the agent, we're basically storing the state, like the entire state of what has been going on at the step. So when someone reports a bug, rather than just literally like reading the entire trace and trying to figure out where things went wrong, first of all, we pinpoint at which step the issue has happened. And then we replay that trace on a new code base where we try to fix the bug and see if the agent behaves differently. And we do this fully automatically. Like we go to the LangSmith API, we pull the trace, we load it as a state, and then like we kind of replay it. So I think this is the future on how do you build agents in production. Otherwise, the debugging is excruciating.
Yeah, I think this replaying is a really cool UX. We added it into LangGraph Studio natively, but it's also possible to recreate from LangSmith logs, which I learned earlier today. So
there you go.
That's good. I guess I have no clue what time it is, but last question before we maybe turn it over to some audience questions. What are some of the things that Replit Agent is really good at today, and what are some of the future directions where you hope to take it?
Yeah, so for the initial launch, we focus on 0 to 1 software creation. That's what we're excited about. That's the target user base that we have in mind. Like people that are creative, they have an idea about what they want to build, and they want to see the prototype in front of their eyes as quickly as possible. And we talk about AI-first coders, which means not necessarily people that don't know at all how to code, but they rather spend time prompting rather than getting their hands dirty in the code. So we're doing fairly well there, and I think we kind of created this magical experience where like in 90 seconds you see the first prototype of the app in front of your eyes. And we focus mostly on web applications, but you can also build like standard Python apps and scripts and whatnot. We are still not very good at working on pre-existing projects. We have the technology to make that happen, but in all honesty, I think at least I learned the hard way in life that it's always better to launch something narrower scope and learn from the users and gradually add more features rather than dropping something that is very generic and is going to get even more backlash.
That's a really common trend we see as well. Like scope it down so you can get it out the door and then see how people actually use it, because they might use it in ways that you didn't even anticipate.
Which we discovered very quickly after launch.
Actually, to that point, what was one of the funnier things or most unexpected things you discovered about how people would use it?
I would say most unexpected is that we have a mobile app that tries basically to offer the same features we have on the desktop app, and we have way more runs than we ever expected on the phone. A lot of people love to pull out the Replit and build an app in 2 minutes and brag about it with their friends, or even use it on the spot. That was by far the thing that I love the most. And the other one is also seeing the variance between how people express themselves when they create the initial prompt. Some are very concise and terse, and to be honest, also fairly ambiguous. So it kind of shows that there is a user base out there that never spent time learning how to do prompt engineering, which totally makes sense because not everyone is in AI. And on the flip side, we also have people that are very thorough when it comes to giving instructions, to the extent that they copy-paste entire markdown files. And sometimes it works spectacularly well. Sometimes they're asking things that are fairly impossible for the agent to pull off. So we end up ignoring most of the instructions. But yeah, that's what happens with an early access program.
All right, so everyone's going to go copy-paste markdown files of instructions.
Please let me know.
Any questions in the audience? Yes, I saw Rex first. And I will probably repeat the question for the microphone, but feel free to speak loudly.
Yeah, Rex here from U.com. I've played with Replit Agent. It's great. One of the things I noticed really quickly is once you start to get somewhat more complex, you can start to see this notion of the SFT helpfulness of it really emerge. It would tell me things like, oh, our engineers are looking into it, I'll get back to you, right? And we take no action. Unless, I don't know, you have your guys, coding behind the scenes.
No, we're not enough people to do that, trust me.
I guess my question is, as you've gotten more advanced in these agents, how have you thought about the trade-off of the SFT helpfulness of these models and the risk of maybe, to me it felt like you didn't know what action to take, so you took none and pretended you were being helpful. Have you thought about that trade-off as you get more and more complex?
Repeating the question for the mic, have you thought about the trade-off between the SFT helpfulness of the model versus taking action, especially as they get more complex?
Yeah, we did. We are getting a lot of feedback about the fact that the agent talks about the team, and that's why I like to be very public about the fact that it's a multi-agent system and we design it as a team. So as you know, it's going to be impossible for us to hide that aspect completely. And to be honest, I don't even want to hide it. I think.
So when it says the engineers are working on it, that's the other agent engineer. It's
the other agent engineers. It's not Replit engineers. Again, our team is too small to pull that off. I wish we could, but no, we're not outsourcing anything to humans. So that being said, that is happening by means of us prompting the system in that way. the trade-off, I don't think there is any way for us to overcome it today, because ultimately we're relying on frontier models where there is a lot of SFT and RLHF happening. I would say the issue that you experience, and I really hope, is mostly due to a bug rather than us deciding to be inactive. So we don't have any logic in the agent that says, if I don't know what to do, I'm going to be passive and just ghost the user. It just happens, and we keep making progress, especially on longer trajectories. Sometimes the thinking time is way too long, and that's why it appears to be inactive. But most likely you hit a bug rather than us deciding that we didn't want to make progress.
Another question right here.
How did you guys think? Do you think about evals in this? Seems like lots of evals will be needed.
How did you think about evals?
I love evals, but we have such a lack of good evals in this space. Of course, like everyone, we tried to use WebBench to an extent, and it definitely helped us to test the core loop of the agent. Like as I mentioned before, our main core loop is like a variation of React, so pretty much what everyone else is doing out there for coding agents. It helped us to debug only that part of the system, but it doesn't really help to test end-to-end the entire experience of Replit Agent. We built parts of the eval, the ideal eval that we have in mind. Honestly, like I think many other launches out there, I'm not ashamed to say that we launch also based on vibes. So we use it a lot internally. We felt that it was good enough, and we made it very clear that it's early access. So we tell people that the product is limited, and I think you all guys are helping us to evolve. There is a near-term future where our verifier sub-agent is going to become even more powerful, and then we're going to try to mimic the same actions that the user does on the artifact that we create directly through the AI. But it's hard for me to think of that as a public eval that the entire industry is going to agree upon. I wish someone in academia is thinking of working on that, because I think it would be an amazingly useful contribution. Or even as a company, it doesn't have to be coming from academia necessarily.
Another question, Swix.
Hey,
Yo.
did you look at agents controlling other agents, like swarms of agents, crews of agents, whatever you call it?
Yeah, we look at them. I would say we try to strike a balance between being too simplistic, so like the initial React-only loop, and then going towards an architecture that require like too much message passing between too many agents. So I think right now having like 3 or 4 of them makes it still relatively easy also to debug. Like right now, in a lot of our traces, we see that the manager is handing over the editor, and the editor is doing a series of actions, and then the verifier kicks in. So for us as human debuggers on the other side, it's fairly easy to understand what is going on. I'm afraid that if we add even more complexity and we make the swarm even bigger, we will kind of lose control of what the agent or what our architecture does. I do think we need the next level of accuracy and instruction following from models to go in that direction.
But big gain from just one agent to manager agents.
Very big gain, yes. Yeah, like having a catch-all agent with all the tools in scope and a very generic system prompt, I think it's a recipe for disaster. Well, it helps you to build up to a certain extent, but the moment you need to build something as complicated as a coding agent, you're going to hit the ceiling very quickly.
Question right there.
Yeah, hi. Great product, by the way.
Thank you.
So curious to know if you take advantage of any parallel execution with the consensus mechanism before you respond to results.
So we don't use any self-consistency, although I would love to. And the reason is it's very expensive. So if I was sitting on a LLM provider, then I would be definitely burning more tokens. But the truth is, we cannot trade off self-consistency. So like the idea of generating multiple LLM calls to see if there is an agreement between them, we trade it off with higher latency, and with the fact that in a React loop, you reason, you take an action, you see the outcome of that action, and then if the outcome is not what's expected, you keep looping until you make progress. So I think that is a good trade-off. That being said, say 6 months from today, there's going to be a Sonnet Mini, or like the new ICO is going to be extremely fast and as powerful as this model. I wouldn't be surprised if we had a release that either use self-consistency, or even more exciting to me, ultimately, Replit has like this very interesting environment where you can spun up different repos. Each one of them is assigned to a different container. So you could think of basically doing MCTS with the agent. You have the same prompt, you kickstart a different agent session on each one of them. They make progress in parallel. And then at certain points in time, you try to sync and see which one of them are in agreement. And then you drop the trajectories they're filling. All of this, I think it's in the realm of feasibility. Cost, as of now, is prohibitive. So, but like anything in AI, cost is dropping so quickly that maybe next year we're going to be here chatting about our parallel agent evaluator. Yeah.
Thanks.
Awesome. We'll probably do 2 more questions, maybe one right there.
If you were to do the joint effort again, and from manifesto to deployment, how would you do it differently? Learn from mistakes that they made.
Repeating the question, if you were to do it again from the initial manifesto to the final push for the agent, what would you do differently? What mistakes did you make that you'd rectify? Generally, maybe speaking, what advice would you have for other people doing similar things as well?
That's a great question. I wish I had time to sit and think and do a retro. I don't think we have too many regrets, to be honest. Maybe if anything, we kind of understood the product we wanted to build, why we were building it. So perhaps having had a clearer vision, like back in the days, like I'm talking about the beginning of the year, that we wanted to build a less autonomous agent and more product oriented rather than oriented to like creating GitHub PRs. Perhaps it would have made it easier to make some choices. Like eventually, everything that we shipped, I'm very proud of, and I think that's exactly what we wanted to put in front of people. But I don't think there is any clear recipe like on how to build good agents today. So maybe my recommendation for everyone is don't fall into the paradox of choice, where there are too many ways in which you can build agents, too many different ways in which you can think of a product. Start building, because you're going to change your mind throughout the process. Models are going to change perhaps also in the meantime, so you will find an unlock just because there has been a new release. And in all honesty, the switching costs are not that high. Like switching models, not too much effort, you just have to redo some prompt engineering. Switching cognitive architecture with LangGraph, few lines of code. So I would rather be biased towards action rather than architecting.
Back there.
Hey.
Question for you, kind of two-part question. Replit is a place where people go and actually learn code as well, in addition to just building and deploying this. I immediately bought agents, super cool, and then it like forced me into Flask. And I'm like, can I get a test API? It's like, no, actually, let's do Flask. It felt like a senior developer trying to like force me into like a decision. And so that's one part of how are you guys thinking about like teaching folks and maybe giving them an ability to try other stacks. And to follow up to this, teaching also about prompts. You said that some people basically don't do any prompting, some people face markdowns. What do you think is Replit's position in actually like teaching folks after you see multiple people using this in different ways, you see what doesn't, of teaching them how to actually prompt better this agent?
Repeating the question, teaching people in 2 dimensions. One, kind of like how to code and giving them more optionality in the tech stack that they're using. And then 2, on the prompt engineering side, how much responsibility do you take there for teaching people how to interact with the agents?
All right, so the limitations on the stack are there on purpose, not because we are so opinionated that we don't want people to build with other frameworks. It's rather because if you switch like from Flask to Next.js today and you try to build exactly the same product, you will see a huge drop in terms of reliability. And the reason is not because Next.js is bad. The way in which it has to create files in the file system and how strict is the directory structure and the fact that you have to create a lot of smaller files makes the task, our first step of the agent much more complicated. So we prefer to launch something that even though it wasn't making happy good developers like you, it made happy people because they could actually build something that they loved. So I think our target user base are usually people that don't care about the stack that is being used, at least for now. We do have people internally that are currently working on adding support for more stacks. But again, similar to the answer I was giving before, I prefer the bias towards action rather than having something that could perfectly support 5 different stacks. And now, in terms of teaching users how to prompt, we didn't want to be too prescriptive at the beginning. So I would say, I think we all agree that the chatbots are possibly the worst UI for AI today. Like, you never know exactly what the product is capable of doing. And we all wish that we had better UI affordances to put in front of the user. But the truth is, ChatGPT and Claude and everything else out there train the vast majority of users on chatting with AI rather than using anything different. So I thought that was a good starting point. And I see our recurring users learning by how the agent reacts and how the agent basically builds applications depending on how they prompt it. So I thought that was like already a good gym for them to train their prompting skills. Again, very similar to the first time you landed in front of ChatGPT. Like most of the people didn't know how to use it correctly. I do see a near-term future where even the creation experience of Replit Agent will change dramatically compared to what it is today. So not anymore like an empty box where you can write whatever you want, but rather something a bit more structured. But again, you never know what users want before you launch. So I'd rather go for generality at the beginning and then like find what are the right guardrails that make, say, 99% of the people happy.
That's an exciting way to end it. Before people disperse and start chatting, some quick announcements. There will be demos in the second part of the office. So around there's a table upstairs with a nice TV and projector and some more seating, and Swix will set up there. And so if you want to do demos, go around there. Other than that, Michele will be around all night to answer all your questions, or as long as he wants to stay. And let's give him a big round of applause, as well as Jess for putting it on.
Thank you.